Okay, number 15. We've got a bucket of water pulled up 40 meters. Now, what I'm trying to do here is just write down all the information that I got, and then I can think about it. And this is 10 minutes to pull it up, constant velocity, so there's no change in speed or anything like that. And we know that in 10 minutes, 5 kilograms of water drips out. Okay, so we have 5 kilograms for 10 minutes leaks out. So it's 0.5 kilogram per minute. Okay, so the mass is actually decreasing as it goes up. Okay, so we wanted to figure out what is the force that we're pulling up on this, say at some height h. Okay, so what's the force there? So I know the force is going to be the mass times the times gravity. So I want to basically figure out what's the mass of my bucket at any height h. Okay, so the mass at height h. Well, I know that's going to be 20 kilograms minus 0.5 kilograms per minute. Well, I need to figure out what's the relationship between the height h and the time. Well, I know this. I know that it's 10 minutes is equivalent to 40 meters. So that would be 1 minute, approximately 4 meters, or for each meter of travel, 1/4 of a minute elapses. Sorry, not the nicest way to say that. So for every quarter minute, it's 1 meter. Okay, for every 1 minute, that's 4 meters, and so forth. I'm just trying to write it in terms of each meter. Okay, so I know that for each meter, 1/4 of a minute travels. So if I multiply this by, let's see, so if I have h meters, that's equivalent to 1/4 h minutes, right? Or 0.25 h minutes. Okay. In other words, think about this. If it moves 1 meter, that's 0.25 minutes. If it moves 40 meters, that's 25 times 40, or 10 minutes, which is what it's going to take. We know that. Okay, so if I multiply this by 0.25 h here, what are my units going to be? Well, this is 0.25 h minutes is h meters, right? So this is, if I multiply this by 0.25 h minutes, oops, then that's going to give me a formula for the mass at h, at any height h. 20 kilograms minus 0.5 kilograms per minute times 0.25 h minutes. So at any particular height, so if the height is 1 meter, that's 0.25 minutes, right? If the height is 40 meters, okay, then this is 0.25 times 40, or 10 minutes, which is what I want, right? I'm trying to find the relationship between at any given height, what's the time, and that's what this did right here. Okay, so now that I do that, I can go on and figure out what the force is and go from there. So I'm going to go over here and say, so F equals mg, so that's going to be the mass, 20 minus 0.5 times, oops, let me write it neater than that, sorry, minus 0.5 times 0.25 h times 9.8. That's the force that's acting on this bucket at any point, any distance h up from the ground, right? So the work done, what would the work be? The work over delta h distance, because work has to have a distance to be work, right? Is 20 minus 0.125 h times 9.8 times delta h. So the total work is given by, we're going to integrate that from 0 to 40, okay, because I'm lifting this from 0 all the way up to 40, of 20 minus 0.125 h times 9.8 dh. And if you do that, that's an easy one to do by hand. Pull out the constant, and if you do that, you get 6860 joules. Okay, this is a tough one because it involved having to figure out a formula for what's the mass at any time t, or at any position h, that the bucket's moving up. Once I find the mass, then I can use this to find the force, and then I can use that to find the work, and then we're good to go. Alright.